March 2020. A global pandemic emerged, drastically altering our everyday lives seemingly overnight. Offices emptied out as employees began working from home. Students began e-learning to avoid crowded classrooms. Doctor visits went online, and with this, the household battle for bandwidth began. The result? Residential broadband consumption soared, especially in the upstream with the rapid adoption of video conferencing and other nearly symmetrical types of applications. And this spike in upstream consumption is showing no signs of fading per the latest data from the NCTA. Cable operators responded boldly to this challenge, with one operator stating they had completed all planned 2020 node splits by the mid-April timeframe. But our old tricks for keeping up with this capacity demand are reaching their limits. We can't continue to do business as usual node splits as hubs fill up. We just don't have the rack space and power and cooling to keep up. We can't squeeze any more bits out of the hertz of spectrum we have, as most of the world's already at 64 QAM for single carrier QAMs, and we can't add more carriers as, in most of the world, especially the 42 MHz plant, there is no such thing as empty spectrum. But fortunately, new methods are available to help us keep up. Distributed access architectures like Remote PHY will allow us to split nodes and shrink service group sizes. OFDMA will allow us to get drastically more bits out of each hertz of spectrum, and where we do need to allocate more spectrum for the upstream, we have mid-split and high-split architectures waiting for us. So which of these is the preferred solution? In most cases, it's going to be some combination of these. So these solutions are going to be instrumental in helping us keep up, but they're not without challenges of their own. Distributed access architectures can be disruptive to traditional plant maintenance and troubleshooting processes. Split changes can take downstream problems and move them to the upstream. Things like FM interference now is an upstream problem. And for countries that require monitoring of the aeronautical band, significant changes will be needed in that space too. OFDMA seems like the simplest approach because you're only touching the endpoints of the network for the most part, but it has challenges of its own. So each one of these in and of themselves have challenges, but when you mix these options, the challenges only multiply. Change is not new to cable operators, nor is it new to Viavi Solutions. We've been there to help through generations of major transitions in HFC architectures. Let us help you enable a seamless transition to the advanced upstream with our decades of HFC experience, our complete portfolio of end-to-end solutions featuring standards-based and NEM-neutral approaches. So regardless of which option or options you choose, we can help make this transition as seamless as possible. For more information, please visit viavisolutions.com/advanced-upstream or contact your Viavi representative for more details.